Hi everybody, and thank you for joining us at the Microsoft Power BI UK user group. I'm your host Leon Gordon, and it's an absolute pleasure to be back with you this evening, or potentially this morning if you are based in New Zealand, like our presenter, the fabulous Leila Etaati is. I really appreciate her being with us so bright and early this morning. Leila, can you just confirm what the time is there?
Oh, it's 7 a.m. in New Zealand.
Wow, very, very early. So I really appreciate you taking the time to be with us today. And also to the community, thank you very much for joining us. As always, we're back to bring you a feature-packed session from our top presenters within our industry. I'll just go through a few ground rules. As I'm sure you're all aware, we want this to be as interactive and engaging a session as possible. So I will open the Q&A shortly. So please, if you do have any questions throughout, please do use the Q&A functionality, and we'll have time for questions to be asked and posed to Leila at the end. But please do ask throughout so I can collate those and then pose them to Leila. Okay. So before we get into today's session, which is predictive and descriptive analysis in Power BI, I'll just give you a bit of a background on Leila. So some of you may well know that Leila is a double category Microsoft MVP for AI and data platform, which she's held since 2016. She also has a PhD in information systems from the University of Auckland, and Leila is the co-director and data scientist in a company that I'm sure you're all aware of, the worldwide Radicad. She's also one of the bloggers on Radicad with over 800 articles and more than 9 million readers around the globe annually. Leila's also the co-organizer of Microsoft Business Intelligence in the BI user group in Auckland from 2021, SQL Saturday Auckland from 2015 until present, the Definity Conference from 2017 until now, Auckland AI Global Community from 2018 until now, and she's also an international speaker, as I'm sure you're aware by her joining us with her presence today, having facilitated over 200 sessions and full-day workshops. I found out very interestingly that Leila also loves solving jigsaw puzzles, playing board games, and has 2 Akitas to keep her company. Okay, so without any further ado, I will hand you over to Leila.
Oh, thank you, Leon. That's great to be part of your user group and speaking here. And thanks so much, everyone, for coming and kind of listening to my session. I hope that you enjoyed. So as Leon mentioned, that I'm really interested to know about the AI features inside data platform, definitely mostly about Power BI. So this is something that actually when it's come from 2015 that we have Power BI desktop. In the same year, I see that we can do or create our visual inside the Power BI desktop. So that was the first kind of my attempt to work with AI inside Power BI. And I found it really interesting because people can bring their own visual inside there. So when I see that actually, so it's progressing. It's not just a stop to that. So from that year, we have some features and some visual that actually help us to do machine learning. So this machine learning approach can be predictive analytics or descriptive analytics. Predictive, that means that we can kind of do the predict based on what happened in the past. We are going to see what happened, or descriptive to just show us what is happening in a data, what is the natural behavior of data from clustering to others. So this is the kind of the very interesting part because we work with the data. So it's really matter that we kind of know to kind of learn from the data behavior and use that one to predict or see the natural behavior of data. So in this picture, I'm briefly explain what features we have. So on the Power BI desktop, in the visualization tab, we can write R or Python. Also, we have some of the visual that today I'm going to some of them to show you from Smart Narrative, Key Influencer, Decomposition tree, Q&A, Anomaly detection, and of course some of the visual like line chart that we can convert them to Anomaly or cluster analysis. So these are the from visualization aspect. In a data transformation also we have some capability that help us to get predictive analysis, like using Azure machine learning, that you can use regression or classification over there. And also you can use the vision to get the image tag, so it's kind of descriptive analysis. We can do that. Also text analytics. So we are going to see two of them over here, and of course you can run R and Python scripts over there. And so it's not just limited to that. Even in Power BI service, we have that option. So again, we can use some of the Azure machine learning that we already created in Azure website, or we can use automated ML that has been designed through that. And of course, we access again to the text analytics and vision inside data flow. So as you can see, it's kind of available for people who, as a developer in Power BI desktop, and also for the business user inside data flow. So here we have some capability of writing code with R and Python as a developer, or we can develop some machine learning inside Jupyter Notebook and then publish it even with a Python and R there, and then use it here as a service, or kind of using automated ML and again use it here. So these are the different options that we have, and it's make it really interesting, and it should be, because it's kind of data, so it's good to have them. And I hope, I'm looking to see more visual and more kind of capability of machine learning and over here. So let's start with a very familiar one, and that actually recently has come up in just a year, and or maybe 2 years. In the last 2 years actually we have it, that is key influencer visual. So let's be going through there. So key influencer visual is actually a combination of the regression algorithm and decision tree. So is kind of help you to find the relative and what impact on a specific attribute. So I'm going to provide an example of that one. I think of the customer feedback. So I have a table about customer feedback. I'm going to show you that how this one is working. I want to actually rate. I have an attribute named rating. I'm going to analyze that to see that how the rating can be impacted by how many years our customer with us, how many tickets they raise against our actual activity. That means that they are happy or not happy, and also the company size, and of course there is another one, maybe country region also can be one. Oh, sorry, rolling organization. So these are the 3 attributes. Sorry, just let me zoom it. So we are going to see that how these attributes can be related to rating, how they impact on that. It's kind of, I can say this is also a way of the feature engineering in the machine learning. So in machine learning, we have a concept of feature engineering. We are going to see that how these sum of attribute can impact on one of them. And because behind the scene of this visual, this decision tree, so decision tree already used as a feature engineering for classification. So what we have here, so just look at the data first before I'm going to show explain what's happening there. So here we have a rating that has 2 value. So in terms of the machine learning, when we are going to predict a situation that is 2 scenario, we call it classification. So here is actually when we have this situation, we call it a classification, and it can be between 2 to about less than 10 item is actually when you can use this one. So let's see that what's happening in the visual. So under the visual, as you can see here, I'll just make it much bigger. So as you can see here, first of all, you can see the value that we are going to evaluate. That was rating. So what influence rating to be high or low? So we are going to see that what attributes. So this is a descriptive analysis. We are not going to predict. We're just going to analyze to find the natural kind of using ML to show us how it's going down. So I'm just going to check that one. So the first attribute that is found has impact is ticket count. And does it make sense actually? Because when people on kind of happy about us, they rate us high, the number of the tickets that they issue regarding any problem they face is going down, and kind of is makes sense. So as you can see also there is an explanation through that. If you hover your mouse, I try to kind of, let me bring it over here so you can see that. It says that the ticket count decrease, the likelihood of rating is high increase. For example, a fall of 2.6 in ticket counts to lead to a growth of 4.15 growth in the likelihood that people actually rating us high. So it's kind of provide also explanation on what is happening, and also you can see also in the chart that this is the rating. So it's convert the high and low to the percentage. That said, the percentage of the rating to become high is actually as the number of the ticket increase, is kind of, you see they have a vice versa relationship. So as it's less tickets going down, the chance of the rating going high also is, they have a different vice versa thing. So the second one is tenure. Tenure is a number between, if you look at the tenure data over here, is a numeric value between actually 0 to 60. It's better that I remove the blank. I didn't do that, but it's better, always better to doing that. So here is a number between kind of the continuous number, and it says that when the tenure is between 0 to 20 months, actually the data is based on months. That means customers stay with us kind of between 0 to 20 months. The chance that actually they they going to be happy about us is kind of they are kind of impacted to each other. So as you mentioned, when the tenure is between 0 to 21, rating is 1.18. It's not that much, it's 1.18 times likely to be high compared to all values of the tenure. And the interesting part also is mentioned that I will go through that. Let me bring it again. It's talking about the influencer contain about approximately 88% of the data. I will talk about it soon. So as you can see, I can say the most important things that we have that has relationship to the rating and influence on the rating is the ticket count. To be honest, tenure, role in organization, and the other is not that much things. So here, as you can see, data, these are funny things happen. Ticket number was a numeric value. So you can see it showing as a line chart kind of over here, and kind of showing like that is a continuous. But here we don't have a category. We didn't create a group or being the data. We don't use that one. I never going and create a binding data over here. So how it's come as a bar chart? The thing is that is actually because algorithm first try to find a relationship between tenure and the rating, and in a regression way, but it couldn't find it. So it's going to, behind the scene, is going to change the data binding. To be honest, I didn't know what approach they're using, is something behind the scene. And so it's going to actually bind the data and find the relationship between the tenure and rating. So as the first step is try to find this, couldn't find any meaningful relationship. So it's going to convert the data to the binding data and using the classification at the end. So it's the same for I think for the company size, I think, or no, company size is a categorical variable, so it's the same. But for the tenure, we have that. Also, you can analyze it based on the low, so you can analyze it that what is the chance that people rate on low. So again, you see that the ticket counts is the first one come up. So this one is actually comes from the decision tree that behind the scene is created. So it's going to grab the rules from there. Again, you can see that for the law is a bit different because ticket count has impact. Also, you see that now if the people stay with us more than 58 months, there is a chance that also they are going to rate us low. So that's a higher. Also, between 29 and 58 is another one. So you see that we can find more variable impacted on the influence rating low here. So it doesn't mean that they are not the same. It can be different. I talk about the interesting part that is when we're going to analyze the data. So here I'm going to change under the analysis. I'm going to change enable count. That is actually very important part. So enable count. What is saying? So when I enable the count, as you can see, if I zoom it here, you see a cycle happening behind the actually around that. So you can see there is a cycle kind of behind the all value that we have. So what is that? That is actually, so the rating is matter. We can say yes, ticket counts can impact on the actually on the rating, but how much of the population of the data or how much amount of the data has this relationship between them? So for example, if you remember, if I click on the count, you see that is actually is become a bit different because under the ticket counts, if you look at the sentence that is written in the hover, this influencer, the influencer contains approximately 88.20% of the data. So this rule apply to 88% of the data. The second one is actually, so that is 88.29. This one is 88.74. So they are kind of the same. So both of them apply to the 88% of the data. Now let's have a look on the other one. So that's, for example, the rolling organization. So when I hover my mouse on roller organization, you see that is only applied to 28% of the data. So that means that when you have similar likelihood, so when we use that one, we see the similar likelihood. So in this example, they are different. So it has much higher impact. But if they have a similar actually likelihood of impacting to the variable above, we need to look at that count because the has more impact on the data is better. I'm going to check the low one. And I can see that that's kind of quite different. So as you see that the first rule only apply to 11% of the data. So maybe it's not a really valid one. The second one in 32, third one 6, and the only one that is really high is rolling organization. It's really funny. So at this first, we see that actually it has a high impact on the ticket count, but only kind of the couple of them doing that. So that's kind of something to investigate. So when people, behavior of the people when rating us low, it can be much, I can say much into most organization is much influencer, I can say by actually the role in organization. Only a few parts of the data is impacted by ticket count. So that's a kind of the really interesting. So you can actually see that. So if you prefer to show as a how is impacted, you can change the sort by. But this feature is not activated at the start, so you can kind of disable it if you don't like it. So this is the kind of impact. Now we are going to look as a kind of cluster analysis. Is not clustering, but again we are going to create some groups and see that how this group is impacted. I'm just back to the high. So you see that is kind of fine about 6 different segments for me, and the rating, the possibility of the rating to be high in most of them is above 95%, some of them like this one 99. And as you can see here, they kind of have the even size of that. So the first segment has 6,600 rows of the data, segment 2 4,000 something. This is the biggest segment, big segment 3, that has about 7,000, and also segment 5. But the number, you see that they are kind of the same. So I'm going to look at segment 3 because it's the highest, kind of one of the highest. So here I can see, yes, it's contain about actually this 10% of the data. It is, sorry, 70% of the data it has. And these are the people whose their company size is between 5,000 to 50,000. Their role is not publisher, and the ticket count is less than or equal 9%. If I go to the other one that has a lower one, again you can see the same role. Now let's move to the low, because in the low one we have different variable. So here, as you can see, I think these two has the higher one, and and this one has a higher chance, so I'm going to look at that one. So here is actually contained about 4% of the data. Segment 5, again you can find the rules. Sometimes is, it's because it's a machine learning concept, not always bring some insight through that. Okay, so that's the thing. Leon, is any questions? So I know that I said at the end, but because I want to go to the other part, is any question till now?
No problem at all, Leila. We do have some questions, but I think they're going to be more relevant for the end of the session as opposed to this segment.
Okay, sure. So thank you, thanks so much. Another things that we have here, so we can kind of, so the data that we have here is based on the rows of the data. So this is kind of the, this is for the classification, but you can use it for the price. So let me just give me a second. I think I forget to bring the data for the regression part. Just give me a second so I can kind of find it. I'm going to actually, this time, I'm going to work on a data. I just want to show you also the data. I hope that's a one that, yeah, that's a house price data, about 1,400 rows of the data. We have a sales price, and we are going to see that. So in the numerical value, how is actually changed. So I'm going to very fast get the data. I think that's a CSV file. And then, yeah. So this is the categorical variable. I can say we can also analyze data on the other part. So I'm just going to load the data. Just minimize this one. I want to compare. So Control-C, Control-V. And these times we are going to that one, house price. So here I'm going to analyze a value that is about the house price. So that's a sale price actually we are going to analyze, and we are going to see the relationship between that one and some, like for example, we can analyze it based on different things that we can have. For example, year build, this can be one that we kind of going to analyze. There are many things here, overall condition and overall quality, they have the kind of the same thing. So I just bring that lot area that can be impacted, and yeah, I think that's enough for now. So here is a bit different. So here is a numerical value. So as you can see, increase and decrease. So we don't have here, we have high and low because this comes from data. But here is a different analysis, increase and decrease. So here we have increase. I'm going to check that one. So same scenario. I'm not going to repeat things, just with a different one, and the explanation is a bit different, definitely. So when it says when lot area is more than this amount, the average sell price units can be higher compared to that, and it contains about 30% of the data. Just is because of that. The only things that I want to show you here, this is the data that I have. The granularity of the data is based on, if I go through that, the house price, the granularity is based on the each house. Now I want to do the analyze in the higher one, that is the neighborhood. So I just expand that one based on neighborhood, and I said I want to see the sum of the data, or maybe average of the sales amount. So this become totally different analysis. This one is going to kind of group by or aggregate the data based on the neighborhood. So here we need to change it to the average or sales amount. So now the everything that you can see here is going to look at not the house by house, but neighborhood by neighborhood, which is actually quite interesting. So this is a key influencer visual. That's one of them that are really interesting to me. The next one that I'm going to talk is anomaly detection. So anomaly detections is kind of can be considered as a descriptive analytics, because it's not going to predict what is happening. It's going to analyze on the data to see what pattern we can find in the data using some of the algorithm. The one that we have in Power BI is actually is not a separate visual, it comes from the line chart, and it actually you can use that one for that scenario. So let me bring the data. Just hope. Yes. So for that one, just make sure it's not an. We can do anomaly detection by different one, but the one that we have in Power BI is actually based on time. So anomaly detection time series one. So it's not. There are many other approach for anomaly detection, but this one just supports this time series anomaly detection that needs you have a timestamp and the value. I can share the data about that so you can see what's format of the data. You can have it here. So I'm going to use the times, of course, as the access and the value. So this is my data that I have. And so if you go to the format of the data, sorry, under the analytics tab, you can have a find anomalies, and you can set I want to be sensitivity about anomalies. It should be 70%. You can increase or decrease that one. So if I increase, sensitivity goes very higher. If you decrease that one, then so that point is not any. So it depends that how it's on your context of you are going to kind of apply through that. So it's very simple one. You can change the some visual things over here, and also you can provide some more information if you have. I don't have any extra value, but you can set explain by, so you can explain it based on the other categories through here. So this is a very simple part that you can see here. Also, it gives you that what's a value, what the expected value, and expected value range or the confidence level that can be 55 or 68. So this is the expected, and so we can look at that, and based on that we set up our confidence one. That's a very simple one. I hope that we can, this is one of my hope that we can have a separate visual for anomaly detection, and of course for the forecasting. So for the forecasting also we have something here that is not available at the same time, so you couldn't apply anomaly detection and time set at the same time. You need to remove one of them. So when I remove that, now I can access the forecast one that is using different algorithm to do the forecasting. So you can set I want to forecast the next, I think my data is a day level. Let me double check. Yes, so I can set I want to forecast the next 10 days. You can set, for example, with this confidence level, and you can see that, or maybe you make the increase one, and to see more level of the data. As you can see, it's provide the forecast, upper bound and the lower bound. So upper bound and lower bound actually is totally relevant to the confidence level. So if I put it to the 90%, so it can be a bit changed. So it's become, you see, upper bound and lower bound can be changed. This is a kind of the how we can tolerate the forecasting. So it's kind of showing through that. Again, this one a very simple one. I wish that in future we can have some complex one that support the seasonality and the other things through here, which actually here is not provide proper seasonality on the data. We may have combination of the time series that's changed during the season and change during the time, so it's good to have the multiple time series things. So these are the one that we have. So back to the charts that I have over here. So you see that how's key influencer work, how's anomaly detection work. Before I'm going to the others, I love to kind of show you the clustering one very fast here. So I just make the space over here. So again, these are, I can call it as a descriptive analysis that we are going to see. So that's come actually from the we can have it using the scatter chart, so we can have that one. Let me kind of create that one. So English product name. So it's a very simple scatter chart that we can have. So that's a very simple scatter chart that we can have, but still you can use it to automatically find clusters. So when you doing that, is going to create some groups to find the cluster. So here use the k-mean algorithm. That's one of the clustering or descriptive analysis. It can use some of the approach like elbow analysis to find the cluster, but you can also mention how many cluster you want to find and group the data based on that. So here, as you can see, it's going to check the data. So it's going to working on it and to find the number of the clusters. So it's really interesting that you can see it's find about about 1, 2, 3, 4, 5. Actually, this one is blank data because I need to remove them. I didn't remove them, so we can ignore that, but you can see the one. So this is the sales amount between internet sales and reseller sales, and as you can see here, based on the product name, you can see that it can find about 3 different clusters and put them as a legend. If you're interested to see that one as a numerical, kind of as a table style, also is possible. Let me change that one to the table. So as you can see, still in a table style, you're able to see that which point of the data relevant to which cluster, and it's kind of going through that. So is not always to find the relationship between the cluster. This is machine learning, so it's not going to, it's going to find a pattern. If it's find a pattern, then it's going through that. So you can also see the detail of that through here. Again, I totally wish that we can access to the kind of more detail of these algorithm behind the scenes, so we can set up, change the parameters. I hope that in near future we can access to that one, or not just k-mean clustering. We have other one, PCA and the other, that I hope that this comes over here, because this is the data place, so we can work on data a lot. So these are the actually visual, I call them the visual, that they are not separated, they are kind of the different one. I'm going to talk about the actually the last visual that we have here. Decomposition tree is so similar to key influencer, so it just decompose based on that, so just ignore for that one, and going to the narrative visual. So narrative visual is a really interesting one. Is kind of using the natural language processing and going to get insight from all the visual that you have here. So it's kind of, you need to just click on that. And this is a visual that I have. So it's going to grasp some information about what is happening. So here it says that has the hub, for example, at this amount. So these are the actually, first of all, I should mention, these comes from the calculations. So these are the calculation that has been once, for example, that is the percentage difference between max sales amount by English education and max sales amount by education. Or for example, if I click on the other one, is so you can see the data that is going through that, and is provide an explanation on what is happening through your data. So for example, what is the current sales amount, even it is interactive between there. So if I kind of choosing for example, just one of the part is actually all of the story can be impacted. So it's kind of provide a narrative about what is happening in the data to explain that. So for example, across 4 calendar years, sales amount range from this amount to this. So it's kind of provide an overview through that. You can add to that one. You need to set that, for example, order quantity is, sorry about my typos. Quantity is, so here I can add a value over here and I call it as a sum order. I hope that I have it. Order quantity. Yep. Name value, for example, order quantity. Save it. So it's bring the value over here. So you can even able to edit that one and add more value over there. I really find this one also really interesting. You can edit or you can add your calculation over here. So these are the one, just not all of the visual. I couldn't go through all of them in just once, but I just want to preview of the visualization. The next part that I'm going to talk is about the Power Query capability we have. So also in Power BI, in the Power in the Power Query, we able to do some interesting parts over here. One of the things that I'm going to talk about is using text analytics. So text analytics for the premium user is available. So I can, if it's available, if you click on that, it asks you to sign in. So you need to sign in with your premium account. You can have a premium user or premium organization one. So both of them, premium kind of the per person, that was the $20 one, or the other one. So both of them are working. Just a minute. So if you sign in, because I'm already signed in, so you can use that. So I have some hotel comments. I want to see that how much people happy about me. So this series and the one that we have inside the data flow, that is AI Insight, they are identical. They are just one in Power Desktop, another is data flow. So they are identical. So I'm going to apply on the guest comments. If it's other languages, you need to mention, but here is it English, but you need to use ISO code. For example, if it's come French or Spanish, so you need to use that code over here. In this scenario, I'm not going to do that, just going to showing over here. So he's actually using the cognitive services behind the scenes. So I can say that's not a separate one. This is use Microsoft Azure Cognitive Services behind that. It's just a bit take time to connect to the service for the first time, but after that is become, for the first time you call it, take a bit time. So just wait. Okay, so it's actually provide a numerical value for me. So you may mention what is 5, but it has -5 through that. So it actually shows that how much a customer is happy or angry. So this is so minus. So that's a sentiment that we get through that. So 39 is a very high. That means this customer are very happy. Let me just leave this one and this one so we can see the other, remove other columns. So this is again part of the descriptive analysis that you have. Is actually help you to kind of find the analytics on the data. Just I think that's a bit slow. But I can tell that. So you see that the number is something between 0 to 1. So 1 means very happy, 0 means they are not happy. So the last 3 comments, they are so happy people. So the comments should be good. So if I look at that, you see that it's a decent place to stay. Each unit individual. So it's kind of the very good one. I prefer the one. So in the data flow, in the Microsoft Power Automate, we can get actually in the each sentence, because this is just show us the overall. So if it's something combination, we will totally miss that one. So this is a one. Also, if you back here, you can use Azure Machine Learning one. I couldn't choose because I need to create one and show you that how to use it. So, but it's really easy. You can, if you created some Azure Machine Learning model or one, you can actually use it very easy here. I'm just going to show you another one that is I have for the image one. And that's a vision that I have some of the images over there, and is actually going to analyze the data. Let me see if I can access the image that I have. So image tag is applied on the image data. At the same time, also Tenure. Just a minute, also I want to check. So here is actually, I wish that I can show you the images. It's showing to me. So yep, that's the first one. I think is actually this picture. We are playing tennis together, just posing for playing tennis actually. So here you can see is provide the image tag. That's a person over there. And so you can see the confidence of the outdoor posing. Is kind of able to find some of the things. So these are for the first picture, is find 3 tags. For the second one, that is, I believe, this one. Let me show you again. This is actually another one. So it's mentioned that here is a person is a posing tree and outdoor ground, and she wear the yellow color, and the other things that actually you can see there's a plant and the other, and the last one that is actually, as I mentioned, I have 2 dogs, is kind of my 2 dogs over here. So I'm just going to show you. So this is my 2 dogs. So one is Japanese Akita, another one American Akita, and it's kind of going to show them that they are lying. One of them is mom, of course, they are mamas, animal dog. The thing is that the problem with this service in the original cognitive services when you're using is provide more detailed one. So if I can go and show to you, I think we still have time, so I'm going to very fast to show you. Microsoft Cognitive Service 1 API. I hope that I comes to the correct one. So when you're going through there under the computer vision one. For the tags, if it allows me to get, sometimes doesn't allow to get the data, doesn't shows me. So here, for example, in this picture, you can see it's provide more, this also is provide description through that, so you can see the description for the each one. So for example, has more tag. So I hope that they become same, and kind of we see the same experience here and in Power BI. So this is a very general overview. I kind of, if I want to go to the others, it take a bit time, but you see that how it's actually is become easy to work with them. I wrote articles about all of these services I have in Radacard website. So you just search, for example, if you want to learn more about these things. So just for example, search anomaly detection, for example, anomaly detection, just Radacard, and you will kind of see this series of the one also in the YouTube channel, and also inside the our blog post. You can see also I have some of the before they bring actually anomaly detection inside Power BI, I use a API call, and I use that one. So that's also possible, but there is no need to doing that. It's always there. So any topics about this, you just search for that topics and Radacode, and you can find about that. Thanks so much, Leon. Is any question?
Absolutely fantastic session there, Leila. So thank you very much for fitting so much into such a short period of time as well. So we do have a couple of questions. One's an anonymous question which asks, can you show us the decomposition tree quickly? And they also ask, does it use the chi-square automatic interaction detector algorithm, the CHADE algorithm?
It's actually, yes, there's the algorithm, for example, because they use the same. So in K-influencer and decomposition tree, they are actually using the same algorithm behind the scene. So we couldn't access they didn't disclose what algorithm, but they changed the algorithm based on we couldn't change the algorithm, but for example, inside the key influencer, when it's not able to find a relationship, for example, between the tenure and one, so it's changed the algorithm itself. But no, unfortunately, this one I wish that we can have more flexibility sooner, but not in this stage, unfortunately. So I'm going to show you that one very fast. So here the composition tree use the same thing. Just I'm going to the, where's that? The other one I think is better. The customer feedback, I'm going to work on that. I'm going to check the rating. So here, I'm sorry, the rating. So exactly, you see that we have analyzed by, and we are going to analyze by role in organization, tenure, ticket count. So decomposition tree, as the names mention, is going to shows the decomposition of the data over here. So at the top, it shows me the rating, the count of the rating through that. Let me bring this to over here. In the next step, you can actually, so you have 1, 2, 3, 4, 5 actually stations. So first of all, you can don't do any analytics. Just a hint, if there is a lamp sign beside any visual, that means that this is use the machine kind of advanced analytics behind that. For now, for example, I'm just going to see the decomposition of data based on role in organization. So I just click on that. So here, as you can see, if you kind of sum these numbers, it should be equal to that. So you see that 29,000 of the data is people, the role is consumer, publisher, and the rest is administrator. That's really actually good. So now, for example, I can say, okay, that's kind of what I want. So now I'm going to kind of remove that one. And I'm going to kind of going to this time, I'm going to see that what is impact on the consumer one, because they are a big group. So if I click on high value is equal to on the key influencer that I choose the rating to be low and high. So it's actually same experience. So here you see that, so it's actually based on the, let me close that one. So based on the ticket count. So here for the people who are consumer, we want to see that how is impacted by ticket count. So the first one that has impacted, of course, they are higher. So people who have 0 in the next group, people have 2, 1, and the other. You can see the other group. So I just remove all of them again, and I'm going to look at that one. So I'm going to look at the low rating. So it's same things, same algorithm, same approach. The only thing is that they are going to shows based on decomposition of the data. So here we are going based on the tenure. So the first thing that is fun is tenure. I didn't choose anything. It just for the higher one, I see that what is impact on the people to have a lower rating. So the first thing that it actually shows me is tenure, and you can actually see the how is kind of works through that. So you can go to up and see that for the people that kind of how is for the 14 they have much higher actually impact through them. Yeah, so that's the one. Thank you.
Perfect. Thank you very much. And we have a question on coming from LinkedIn from Karanam, and they ask, how would they show rebalancing opportunities or route visuals? So, for examples, aircraft routes, main lines, loop lines, or point-to-point on a map without using Azure Maps or Power Apps?
Oh, okay. That's not a machine learning question, but yes, that's kind of that can be done. So maybe ArcGIS, that's the one answer I can say in the one. So without using them, that's the one that we can use. Also, you maybe check the field map or shape map, but I think with ArcGIS we can do more than on that. I need to double check. That's a good question. I need to double check more.
No problem at all. And as I mentioned, the Q&A is open within Teams as well. So if we do have any further questions, and we do have one more question coming in from Selim on LinkedIn, and they ask, and this one's about stock prices. So how can we visualize stock market prices on Power BI with good quality?
So it depends on actually which one you kind of going to use. So for the stock market, actually, so because it's going up and down, so we can use time series one. So they can use that, or we have some custom visual. We have lots of interesting custom visual showing that you can use it. We have time series one, or some of them. It depends on which aspects of them we are going to kind of show. So one of them is time series that we can use it. That's for forecasting. Also, they are based on that because most of the things is based on time. So they are really interesting time, kind of the timeline one that we can use it. There's the one that I remember once I used. I need to double check the name. I forget the name, but that one is really good for time series. I will check that one and post it in LinkedIn. Can I access to the comments after that so I can reply to them? Or
yeah, of course. I'll be able to send you an extract, and you can know who the comments are coming from. That's no problem at all.
yeah. So I can send some of the example to them. Yeah, sure.
Okay, that's fantastic. It sounds good. I mean, we don't have any more questions coming through just as of yet. We do have a slight delay by using a live event, live streaming. But I believe that for the time being, that wraps us up. So Leila, I mean, once again, on behalf of the Microsoft Power BI UK user group, it's been absolutely fantastic having you with us, and we totally appreciate you getting through all of that fantastic information in such a short period of time for us.
Oh, thank you. Thanks so much for having me, and keep safe and hope to see you soon.
Definitely. And thank you to everybody as well for joining us. You could have been anywhere in the world, but you've been here with the Microsoft Power BI UK user group in association with our sponsors, Onyx Data. Stay safe and we'll see you soon.